Awesome. I audible? Am I audible? Hello.
Yes, sir.
Hello. Very good morning, sir. You are audible, sir.
Yes, sir.
Good.
Okay. So, a very good morning to one and all present with us today. Myself, Mr. Maksud Ahmed Loshkar, Assistant Professor, Faculty of Pharmaceutical Science, Assam Downtown University. I would like to welcome you all on behalf of our department to this webinar. On our today's webinar, it focuses on the topic green extraction, scope, and opportunities. So I would like to brief about I would like to brief outline to our today's speaker, Dr. Dhruv Shukla sir. Dr. Dhruv Shukla sir is working presently as an associate professor in the Department of Pharmaceutical Technology, Adamas University. Sir has also worked as assistant professor in the Department of Pharmaceutical Technology, NSHM Knowledge Campus, Kolkata. Sir has also worked as an assistant professor in Himalaya Pharmacy Institute, Majidhar, Sikkim. And about the qualification of Dr. Sharkar is Sir has completed his M Pharma in Pharmacognosy from JSS College of Pharmacy, OT, in the year 2006. Sir has awarded his PhD in pharmaceutical technology from Maulana Abul Kalam Azad University of Technology, Kolkata, West Bengal, in the year 2021. Sir is having a couple of publications in many national and international journals, like 11 international and 4 national publications with a conference of 10, and he also has published one book in his credential. Now, I would like to take this opportunity to invite Dr. Dhrubajyoti Sharkar sir to please deliver the lecture based on the topic, that is green extraction scope and opportunities. So please welcome sir. Sir, please share your slide and you can continue, sir.
Thank you, Maksud sir. Actually, this is my second time. I would like to give a thank you to
Yes.
all the authority of Assam Downtown University, including the Dean, Dr. Biplab Kumar De, and Dr. Farooq Alam for giving me the opportunity to speak in this platform. This is the second time I'm speaking on this platform.
Yes.
And first speech was on the something that was related to my research, but now today we'll discuss some scope and opportunity where the research can be done. Actually, I'm studying this research area so that Hello. I'm sorry for the inconvenience. Hello.
Yes, sir, you are audible, sir.
Yes.
Please go ahead.
Sorry for the inconvenience. Actually, I
It's
got
all right.
by some internet issues. Anyway, today, without wasting my time or your time, I'll start by displaying the different slides which I made for the green extraction. Is it visible, sir?
No, sir, it's not coming yet.
Just 1 minute.
Now it's coming.
Okay. Full screen, na?
Yes, sir, full
Yes,
screen.
it is blinking. Okay, so green extraction and scope and opportunity. So first we'll go back to the history of extraction. If we go back to the history of extraction, slide is changing.
It's changing, sir, yes.
Yes, thank you. Okay. If we go back to the history of extraction, we can see the extraction of natural products that has been probably since the discovery of fire. Egyptians, Phoenicians, Jews, Arabs, Indians, Chinese, Greeks, Romans, Mayas, and Aztecs. Every different civilization they have their own innovative extraction process. Some are already nowadays also follow in different manner, maybe in different skill, but they are following the same extraction process like maceration, distillation, used even for perfumes, medicine, or food. Nowadays, we can find a production process in the perfume, cosmetic, and pharmaceutical, food, biofuel, then fine chemical industries which does not use the extraction process. In the food industry, besides the well-established huge extraction processes of sugar beet and sugar cane and the preparation of decaffeinated tea and coffee, many formulations have been developed by adding plant extract and nutraceutical concentrates. So this is all about extraction. Extraction is required in the different herbal industry as well as food and in perfume industry. Now, what is extraction? Extraction is a procedure by which the active constituent of a crude drug can be separated out, right? But what is the glitch? Where is the problem of what is the need for doing the green extraction? It is as usual extraction is going on. No, actually, in spite of high energy consumption of the large amount of solvents, even yield is indicated in decimals. So it is taking the extraction process actually taking the 50% of the energy of a industry, and also a very decimal amount of minimum amount of extract is yielded by this extraction process. For example, I can give you example: a single milliliter of rose absolute that weighs less than 1 gram requires not only 1 kilogram of fresh rose as raw material, but also a large quantity of solvents. So and water as cooling agent. So there is a problem. There is a require of the different directives. So European countries they have made directives like REACH, registration, evaluation, authorization, and restriction of chemicals. So the chemical use should be restricted concerning the chemical substance either as such or entering into the products or manufactured objects. And another directive has been given, that is integrated pollution prevention control. Is aimed to reducing the contribution of industry to non-sustainable development. And in this context, the directives also suggest the BAT, that is best available technology, for each professional sector, not only for this pharmaceutical sector or food industry, for each professional sector. In this context, the development of the green technologies and the use of renewable raw material occupy a central role in environmental friendly processes. So there is a need for the green extraction. Now, what is green extraction? A general definition of green chemistry is the invention, design, and application of the chemical products and processes to reduce or to eliminate the use of generation of hazardous substances. So green extraction is based on the discovery and design of extraction processes which will reduce energy consumption, allows use of alternative solvents, natural products, and ensure a safe and high quality extract or product. So it will give the three major solution: improving and optimization of existing processes, using non-dedicated equipment, and then in processes and procedures, but also in discovering alternative solvents. So these three major solutions in green extraction can be. So what are the 6 principles? We are going to discuss the 6 principles in our next study. So this is the main concern of this talk or speech, you can tell. So first one is principle 1, that innovation by selection of varieties and use of renewable plant sources. Principle 2, use of alternative solvents and principally water or agro solvents. Principle 3, reduce energy consumption by energy recovery technologies. Principle 4, production of co-products instead of waste or include the bio and agro refining industry. Principle 5, reduce unit operations and favor safe, robust, and controlled process. And principle 6, aim a non-denaturated and biodegradable extract without contaminants. So in next slide, we are going to discuss the principle 1. So principle 1, innovation by selection of varieties and use of renewable plant resources. So in this context, we can see the increasing demand of natural products and extract is leading to over-exploitation of natural plant resources. History reports several examples of plant extinction because of overutilization. The preservation of biodiversity is therefore mandatory in respect to future generations. In green extraction, fully renewable resources have to be favored either with intensive cultivation or in vitro growth of plant cells and organisms. So in vitro growth of plant cells and organisms already been started by the using tissue culture. And the what we don't know, that is how to do the intensive cultivation, or we can use the different source. Like now we are going to discuss the paclitaxel. You can take the example of paclitaxel. In 1970s, what happened? The paclitaxel, that is a actually Taxol, which is one of the major anti-cancer agent, was used in tons. Like in 70s, I think it is not less than 30 tons of the bark were collected for clinical trials, and 10 kg dry bark produce only 1 gram of Taxol after extraction and purification. So the plant extinct can be extincted at any time. So what we think, we use the green extraction process or green innovation that can protect the plant. So what has been done? The the paclitated cell is extracted from the needles and branches of the different yew tree species. That means that is Taxus, not Taxus brevifolia, but other species, and from the needles and branches. Okay, so that can reduce, that can protect the plant, number one. Number two, another procedure is there, that is plant milking. You can see the diagram here, plant milking. The artemisinin actually extracted from wormwood, tropical wormwood, then name is Artemisia annua. So the artemisinin is a very potent antimalarial agent. So this antimalarial agent, if you use for all the malarial diseases, the plant maybe get extincted. So we are using plant milking. What happened in plant milking? The plant milking has developed for a production of extraction of substances of interest without destroying the plant. Plants are grown in greenhouse in a liquid medium, and secretion and exuding of substance through the roots of the culture medium are triggered by physical, chemical, and biological stimulation. And the substances is then collected by standard extraction and purification methods. So simple thing. First means we have to grow in a liquid medium. This in a liquid medium, like we have done in case you can tell the tissue culture or transgenic plant, wherever the chances are there, that plant milking is like the same technology used. Okay. Next principle, that is use of alternative solvents and principally water or agro solvents used from agricultural resources. So here is the main scope of research. This is the area, this principle 2 we are exploring, because I have seen many of the different countries, the scientists, they are innovating or patenting new solvents for doing the research and to get the different extracts from the known plant, okay, because these petrochemical solvents which we use that are actually flammable, toxic, and may cause the greenhouse effect. But if you replace them with the biosolvents and agrosolvents like water or different agrosolvents, like one example has been given, terpenes such as D-limonene, it can be it can be used for extraction of the fats and oils. So many examples are there. So this is the area where the pharmacognosy people or phytochemistry who are interested in the phytochemical researches, they can give focus on this. Okay, the principle 2. Next, we'll go for the principle 3, that is reduce energy consumption by energy recovery and using innovative technologies. So first of all, we should know what is the optimizing the existing process. Extraction is particularly affected by environmental and economical factors that requires a massive reduction of energy consumption and waste produced. So waste will go for a next anyway. So hydrodistillation, we can take the example of hydrodistillation. Hydrodistillation is an ancient technique for extraction of essential oil. It is used worldwide for its simplicity but requires high energy consumption for heating and cooling. When the process is carried out under moderate pressure, distillation time is reduced to a factor of 2 or 3, with a reduced consumption of steam and hence reduced energy consumption. Some aromatic plants such as sandalwood, then clove, you can tell rhizome of vetiver, ginger, iris, whatever the extraction process which can be done by for the volatile oil, that are very time taking, maybe 24 hours are required. Okay, but if we increase with if we less than 3 hours, if we give the pressure steam distillation, if we apply the pressure steam distillation, it can happen within 3 hours. Okay, so this is the optimizing the existing process. and recovery of the energy liberated during the extraction process or reduction of the energy consumption can also be done by a prototype of by eco this also on the now because this is not fully developed, only a prototype of eco evaporator able to recover 55% of the energy, and what is developed in the south France of steam distillation of lavender. In case of lavender extraction, that has been that eco prototype eco evaporator has been introduced, and this is under the study till date, and there is also scope of doing research on this. And next one is the assisting existing processes with intensification. Yes, intensify how the process can be intensified. We can use the ultrasound assisted hydrodistillation, and full process innovation can be done. We can use the pulsed electric field, which can actually faster the process. Number one, and faster the every process means the extraction is not a only part. It has different parts, and all the under the pulsed electric fields, which can facilitate the timing, which can reduce the timing. Okay. Next, products instead of waste to include the bio and agro refining industry, and from the industry we'll get waste, we can get byproducts, we can get co-products. So first we have to know what is waste, what is byproduct, what is co-product. So waste is any material that industry has only choice to eliminate by waste disposal center, incineration, and landfill. Byproduct is a residual product that appears during the extraction process. It is unintentional and unpredictable, but it can be used directly or be an ingredient in another production process or manufacturing process, and be used as finished product also. So byproducts have economical values. For example, we can give the oil cakes like sunflower, flax, or we can see the uses of different sunflowers and flax seeds, etc., as a food, cereal grains, then wheat pulp, potato fibers, proteins, etc. We can use, and these are the byproduct, not the main product actually. Next comes the co-product. So co-product is a material intentional and inevitable, creating during the a single manufacturing process and at the same time as the main product. The main final product and co-product must always meet specification for their characterization, and each may use directly for a particular application. Now, our aim in the green extraction to minimize the waste and or convert the waste to the byproduct, if not co-products. So we have to use the bio refineries for this. So new green strategy is transformation of the agro products, means like the waste to the byproduct, and if byproduct is produced, then to should be converted the co-product by the process, and that process and biorefineries. We can give the example of rosemary. So rosemary is an aromatic plant well known for its antioxidant properties due to polyphenolic compound such as carnosol, rosmarinic, and carnosonic acid. I have actually worked in the rosemary in my MPharm time. Anyway, after distillation of the essential oil, the residue can be reprocessed in to extract natural antioxidant. It is very high demand by the agro-food and cosmetic industries. The transformation of the oils, you can take the this is the example of rosemary. You can take the example of oil seeds. So the transformation of the oil seeds into food oil generates a large volume of byproducts. The oil cakes rich in protein from pressing seed are generally used for animal feed. So we should not go for the waste. We can go for the byproduct and co-product using the different and that will under the purview of this green extraction process. Next is principle 5, reduce unit operations through technical innovation and favor safe, robust and controlled processes. So it should be intensified process. The compact production unit and reduced unit operation resulted in reduction in cost and better use of energy. So here we are not uh, cutting the different processes, we are cutting the different unit operation in the industry are a very large scale. If you are going for any industry visit, you can see many units are there. If we uh, compact if we use the compact production unit and reduce the unit operation, that will resulted in reduction of the cost and better use of energy. So here we are aiming by this principle, we are aiming for the saving the energy. Okay. Example, you can give the lavender oil by supercritical fluid extraction. So we know from the ancient period, the extraction process of the volatile oil are hydrodistillation or steam distillation. But if we use the supercritical fluid, which is actually in your syllabus also, in the syllabus of the UG, so supercritical fluid like CO2, okay, then the lavender, the extraction will be easier, and number two, the recovery of the lavender oil will be more easier, because if we evaporate the supercritical fluid, then we can get our liquid or desired active constituent very easily. Next one is the aim for non-denaturated and biodegradable extract without contaminants with green values. So here with the extract, many other contaminants may come in the extract other than the desired components. Okay, the whole extract is a mixture of bioactive compound and other substances that can affect solubility and absorption. The composition of extract can therefore influence in the favor and bioavailability of the different secondary metabolites. You can tell alkaloid, polyphenol, flavonoid, terpenes, etc., etc. It depends on the source which we are doing. So to minimize the removal of contaminants, we use LCA, that is life cycle analysis. So this life cycle analysis is based on the concept of sustainable development, providing an effective and systematic means of assessing the environmental impacts of the product, a service or process. This assessment tool is applied to various categories of environmental impact, which have the potential impacts on the environment of a system that includes all the activities associated with the product or a service. So removal of contaminants cannot be done by means we cannot filter it. So the process, we have to do it by process. The process is called life cycle analysis or LCA. So these are the 6 principles by which the green extraction can be possible in analytical scale as well as the in preparatory scale. But in our in this context, why I am giving this lecture, that is based on the principle 2, where we can use the different agrosolvents or we can use the different fruit juices to extract the different active constituents, maybe non active constituents, but in a different process, and it is very easy to get the patents. Some 1 month back or 2 months back, I have seen one scientist from Thailand. He has done a very good job by extracting the mango stem by using the nariyal pani, coconut water, and he has patented that process. And he has patented the process, and some industry, herbal industry, has been taken the patent, and this is a very good innovation. And I think in the pharmacognosy, who are in the field of pharmacognosy or who are in the field of phytochemical research, they can use this. Anyway, so what are the conclusions? We can take the conclusions from here, that extraction according to the 6 principles of green extraction of natural products is a new concept to meet the challenges of 21st century, to protect both the environment and consumers, enhance competition of industries, to be more ecological, economic, and innovative. The concept of green extract is introduced, and extract obtained in such a way to have the lowest possible impact on the environment, and whose eventual recycling would have been planned for. Co-products and biodegradability. As I told earlier, we are minimizing the waste. This green extract should be result of a whole chain values in both senses of terms, economic and responsible, starting from the production and harvesting of the plant and the transformation processes of the extraction and separation and the marketing. So these are the references where from I get the information. Thank you.
Yeah. Thank you very much, sir, for the magnificent presentation and enlightening in us with your knowledge and experiences on this green extraction, its scope and importance. So I'm sure all the student and faculty members have benefited from your wonderful lecture. Sir, with your permission, can we move to the question answer session?
Yes, please. I'm open for it. Whatever I get from the extraction process,
Sir, I have received two different questions. One is, the first question is, sir, what is the principle of ultrasound assisted extraction?
Okay. Ultrasound assisted extraction is nothing but extraction where the ultrasound has been given. That means the extraction where we are using the solvent, we are we are placing the solvent and the drug in the ultrasound region where the sound actually, the wave produced from this, which actually causes the extraction, which is causing the cell rupture, easy cell rupture, where the active constituents can get out to the solvent very easily and in lower time.
Okay, sir. Okay, thank you, sir. We have another question. By this green extract, what are the novel formulations that can be developed, and what may be the importance of those formulations in the society?
Yes, formulation means first the extraction has to be done, then extraction we can go for the formulation. So for extraction, I can tell the formulation can be done for anything, but first of all, we have to know what are the products we can get from this extraction process. So green extraction basically can be done for any herbal product, whatever we are extracting with maybe NHN, with benzene, with chloroform, we can extract it with the green solvents. Number
Okay,
one.
sir.
Number two is these extracts can be then processed normally for the formulation, and we can go for the formulation part, and we can sell the formulation to the industries, and we can make the drugs after the preclinical and clinical studies. So that are the usual procedure. This is the preliminary procedure to get the different extracts. Okay.
Okay, sir. So thank you very much, sir, for answering all the questions posted by either student or faculty members.
Thank you.
And thank you, sir. Thank you, everyone, for your valuable presence. Stay safe and have a nice day ahead. So we can end our session here.
Thank you, sir. Thank you.
Thank you.